Hi, I'm Madison, and this is the quantum mechanical model of the atom. This model contains electrons, waves, particles, and orbitals. The electrons in this model rest on different orbitals, known as, and these orbitals come in stages S, D, P, and F. This is an image, and the S orbitals appear in a sphere. P appears in dumbbells, and D appears in clovers. The F is so clustered that it's an indescribable shape. And the electrons themselves contain spins, and these spins can either go down or up. And if an electron is on the same spin or is on the same orbital as another electron, they have to spin opposites. So that means that there can only be 2 electrons per orbital. Now, in finding how many electrons are in an atom, you can use this model, and this model uses the s orbital, and it allows you to estimate where the electrons would be. Now, in 2s and 3s, you can see there are nodes, and these nodes point to where there cannot be any electrons, so it makes it even easier to find them. Electrons also have a constant mass and a constant velocity. The constant velocity is 2.2 times 10 to the 6th meters per second, and the constant mass is 6.626 times 10 to the negative 34th kilograms times meters squared per second. Now, in the model, there are waves, and there are 2 different kinds of waves. There's a standing wave and a destructive interference. The standing wave has nodes as well, and it can be found in music. So when you if you were to strum a guitar, you would be listening to a standing wave, and then the destructive interference can cause the cancellation of waves because the circle does not meet it. And then there's also particles, and the particles have proportional wavelength to particle mass, and particles can also be seen in waves. So yeah, the particles can also be seen in waves. And de Broglie, he hypothesized that particles could also have wave-like properties and vice versa. So he came up with this equation, and it helps you figure out the wavelength of the particle. So that is basically it. That is the quantum mechanical model of the atom.